All right, so in this video, we're going to talk about POCl3 and pyridine. Now, in the previous video, I talked about a compound called POCl3. POCl3 is used as a way to do substitution selectively for SN2. POCl3 is going to be our way to selectively do substitutions for E2. Now, like thionyl chloride, this does have some similarities and some limitations. First of all, both of these react with alcohols. The second is that, like thionyl chloride, POCl3 is pretty water sensitive. So if you want to run this reaction, it has to be under neat conditions, meaning air-free and water-free. So it is a limited reaction, but it is still a useful reaction. So for POCl3, what we're going to do is react an alcohol. And this alcohol can be of any order. It will eliminate through Zaitsev rule, meaning that the most substitute carbon is going to be the one that we eliminate from. So when we do this, we're going to eliminate from here and not here. The challenge with this, though, let's put some stereochemistry on this, is that it is a stereoselective reaction. Because we are doing E2, we're always guaranteed to create a certain type of product. So first thing that's going to happen is we're going to react with POCl3. And the POCl3 here is going to react with the alcohol. Give us the POCl2 bound to the alcohol. Next thing that's going to happen is our pyridine is going to abstract the hydrogen that is anti-periplanar to this POCl3. So it has to be on the opposite side. So what we need to do is we need to rotate this molecule in such a way that the hydrogen and this POCl3 group are on opposite sides. So if I take this compound and I rotate it, what I'm going to get is hydrogen up, this ethyl group out, this methyl group back. And then for our alcohol, we want to rotate it so it's on the other side. So this is going to put this methyl group back, this POCl2 group down, and we're going to have a hydrogen up. So this is how we're going to do it with the pyridine, is that the nitrogen is going to abstract the hydrogen, break it, and what we're going to end up with when we're done is an alkene, but specifically it's going to be an alkene, in this case, where the two methyl groups are cis to one another. So this is the real complication with POCl3 and pyridine, is that you're only guaranteed to get one stereoisomer, that's it. And particularly with these alkenes, you're probably going to need the modeling kit to actually figure out exactly which way it works out. So we're not going to get a mixture here of the cis-trans methyls. We're only going to, in this case, get the cis form. If this were wedged back, we get the opposite. We would get the trans form. So again, very useful, guaranteed to give you E2, very stereoselective, but like thionyl chloride, very water sensitive, needs to be run in neat conditions, and it's going to be a bit more of a difficult reaction to do.